All right, so on our indicator pressure, if we are given this part where we are given the indicated mean effective pressure, that affects our internal combustion engine. In this case, we have got what we refer to as the indicator diagram. And this indicator diagram is used to calculate or to determine this pressure, which is the indicated mean effective pressure. So when we are given this, according to our calculations, we shall talk about that. How are we going to have the calculations done? But in this case, that is the most important part of our diagram. We have got, in this case, the pulley, which is the sliding board, the pencil that you're given, the indicator card, the spring, the rod, the piston, the cylinder, and the cylinder working pressure. So we are saying to find the amount of work done on the cylinder of such an engine, it is essential to plot a pressure volume diagram during the movement of the piston inside the cylinder. This is done automatically by the indicator, the engine indicator, which is this one. So instead, that can be done automatically by the engine indicator. So I want you to just go through and understand about this indicator and so forth. But what is important is that it is going to help us, this indicator part. It can be summarized in form of a simple diagram. So whenever you are given information which focuses on the indicator diagram, because you wanted to say, I'm having information on our internal combustion engine. Yes, you're supposed to calculate the indicated power, this and that. But you see that you be limited somehow, that you are not even having that indicated mean pressure. And you are not even having even the mechanical efficiency, anything that you can think about that you need to determine the indicated mean effective pressure. On that case, you'll be forced to work from your indicator diagram. And they will give you the indicator diagram information. So the information about our indicator diagram, it is you'll be given the area and the length in most of the times. So this is your diagram you must have. In this case, this is our height. And this is our length. So this is our length, and that is our area. As we know that area is equivalent to the product of these two. That is the length times the height, or the height times the length. This is about the area. We shall talk about the units later on, but we know that this is in the square units. Okay. So given this diagram, remember our focus here is not about the area. Our focus is about the indicated mean pressure. So I'm just going to write PM for the indicated mean pressure in short. Indicated mean pressure for this diagram, the indicated mean effective pressure. Effective pressure. All right. Let's say we want to calculate PM in this case. So PM is given from the spring stiffness, which is the spring rate. You'll be given the spring rate like its pressure per a certain unit of length, which is the unit of the height that you're given, I mean. So that is given as the height times the spring rate, or the spring stiffness. This is the formula that we need. The spring stiffness. So the height, the spring stiffness, is simply the spring rate. What am I trying to say here? Remember, we need the indicated mean effective pressure. All right. And the spring rate is the rate that we are given for the pressure. If it is the rate for the pressure, it is given per unit height. this spring rate, let me talk about this. It is given as the pressure in Pascal, or it's kilopascal, whatever that you're given, per height, per height. So you'll be given the units for that height. Is it in millimeters? Is it in centimeters or what? So if they say kilopascal per millimeter, it means your height must be in millimeters. If they say kilopascal per centimeter, it means your height must be centimeters. So the spring rate, which is the pressure per height, per unit that you are given of the height, affects also your height. What am I trying to say? Kilopascal per centimeter, this height must be in centimeters. Kilopascal per millimeter, it means your height must be in millimeters. That is the idea. But in most cases, you see that they are not going to give you this height. It will be a direct question. If you're given the height, you just multiply, you're done. So they want you to find this height from where they will give you the area, they will give you the length. They will need you to find the height from there. How is that possible? Remember, we say the area is the product of the length to the height. So that means if I divide this by the length, I'm obtaining what? The height. We divide this by the length, we are obtaining the height, which is equivalent to the area over the length. If this is in square units, it means this is in units. So the moment square units and units cancel, you're going to remain with the units. So what am I trying to say? If this area is in square centimeters, you must use your length also in centimeters so that you obtain the height in centimeters. If this is in square millimeters, your length must be millimeters so that your height will be millimeters. Yes, you can change your height from later on, or you change the units to the suitable units, or you find it in millimeters. Then depending with the spring rate, which we said it can be kilopascal per millimeter or kilopascal per this unit that you're given, you change to those units. But this is how you are going to find your height. Like I said, in most cases, they are not giving you, they are not going to give you this height. You are the one who's supposed to find it. The spring rate you'll be given, all right? So this is going to give us the pressure, depending with the units. Is it pascals or kilopascals? That is the spring rate. If it is pascal per this unit, then your answer is going to be in pascals. If it is kilopascals per, your answer is going to be in kilopascals for the indicated mean effective pressure. So this is the indicated mean effective pressure, which we're using in our formulas. Remember, we were using this, or we were writing this in our formulas as P indicated mean. This is the same effective that you're talking about. So you can write P indicated mean. So thus, if we have this, remember, we can calculate the indicated power also from there. Remember, from the formula plan, from our plan formula, which we are told that from our formula sheet, this is P indicated mean. We have this formula from our formula sheet. And I talked about this, that if this is in kilopascal, it means your answer is going to be in kilowatts. And I talked about this, and this. So these are some of the questions that maybe you might have later on. Also, talking of the efficiencies, remember we talked about those efficiencies. It can be it can be the mechanical efficiency. It can be any efficiency that you might need to relate between the brake power, the indicated power, all those things, all those formulas for the brake power, because all these questions now we are now combining everything at once. But this is what you need on the indicator diagram. All right, let's check our first example that we have before we check other questions. We are given there, example number 1, that an indicator diagram, take note, they told us there, an indicator diagram obtained from a test on an engine is the following: the length and the area. So this we are given an indicator diagram. So we know that this information is from the indicator diagram. All right. So from the indicator diagram, we know that we're going to have something of this nature. What are we given there? We are given the length in millimeters. So this is the length, 70 millimeters. And also, we are given the area in square centimeters, our area there, which is 19.6, that's square centimeters. So like I said, you're supposed to also have the what? The height, and use it to calculate what? The indicated mean effective pressure. So they gave us on this question the spring rate, which is the stiffness of the indicator. The spring rate is the stiffness, like I said. So it is the pressure per unit of the height. So they are saying the spring rate is given as what? Our spring rate is given as 20 kilopascal. So this is 20 kilo per watt per millimeter. Like I said, it is given per height, but that height is in millimeters. Calculate the mean effective pressure. All right, this is what we have. So like I said, from our information, the indicated, indicated mean effective pressure, PM, must be taken from the height times the spring rate. Once you know this, you are done. It's height times what? The spring rate, which is the stiffness. The spring rate is given in kilopascal per millimeter. Per millimeter. It means our height must be in millimeters for us to use kilopascal per millimeter of the height. But we have the height. No, we do not have. We have the length, not the height. So we must determine or have the height. Remember, from that information or from this part, I said the height is area over what? Length. Then we use it to calculate this height times what? Spring rate. So that's it. So we need the height from the area. Height is equal to the area over the length. But take note, these two must be given in the same units. So most of you guys, you find it difficult for you to convert square units in terms of area, maybe this to square millimeters. So it is best that just change what you are used to. You can leave the area as it is in square centimeters and change the length to centimeters. You are used to that. How do we change this to centimeters? Just divide by 10. So this is 7 centimeters. So that means we've got 7 centimeters. So H, this is square centimeters, this is centimeters. So if we divide, our answer is going to be in centimeters. Square units divided by centimeters. So our answer is going to be in centimeters, which is 2.8 centimeters. But like I said, you use the units as you are given on the spring rate. It's per watt, per millimeter. So this must be converted to millimeters now. We are used to that conversion. It's easier for us, even if you have to convert again. 1 centimeter is 10 millimeters. So we multiply by 10. That means we've got what? 28 millimeters. So this is our height in millimeters, which is the one needed in the same units. So we've got 28 millimeters times the spring rate per millimeter. That's why. So this is 20 kilopascal. So like I said, this is millimeter. As you can see, guys, if we say millimeter like this times kilopascal per, I said per means over like this, divided to millimeter like this. So what's going to happen? This will cancel. You are left with what? Kilopascal. So your answer in this case is the pressure direct in kilopascal. That is the idea there. So if you multiply 28 times 20, that is going to be 560 kilopascal. So that is our indicated mean effective pressure. That is how you can use this provided that there's a necessary or the information is complete to calculate the indicated power, we can do that. Like these questions that we see on this activity 2.2, just going to do 1 or 2 questions from there that needs us to apply this. So we are given on question number 1. Let's see question number 1. It's all about the indicator diagram again. So there they gave us that an indicator diagram, that's what, an indicator diagram obtained from a what? A 4-stroke single. This one is not about to say, this one is all about the cylinders that are there. The 4-stroke single cylinder, that information is not to say it has to stick to the indicator diagram. No, it can be just used anyhow, as long it is about the engine that you're given. So there we are given what? The 4-stroke. So our engine, it's a 4-stroke there. So it's a 4-stroke. What else do we have? A single cylinder, the number of cylinders, that's 1. All right, let's see about the indicator diagram. So on the indicator diagram, we're given the length 75 millimeters and the area of 6,24. This is on the indicator diagram. So the information about the indicator diagram is this one. The length, which is 75 millimeters, right? As we saw that if the area is given in square centimeters, like what we are given here, this is 6,24 square centimeters. It means also use your length in centimeters, just divide by 10, that will be 7,5 centimeters. All right, then we've got the height in that case that we are not given. All right, so this is the indicator diagram. We're done. Leave it like that. What else do we have on this? They gave us the spring stiffness. The stiffness is the spring rate of the what? The indicator diagram. Per millimeter, 100 kilopascal per millimeter. So the spring stiffness is the what? Is the spring rate. So the spring rate is given as 100 kilopascal per what? Per millimeter. Okay. The engine has a piston diameter of, this is no longer about this. Okay, let's just take this one aside. The diameter 250, which is 0,25. The stroke length 400 millimeters, you divide, which is 0,4. So this is just a normal information about our engine. The diameter in meters, 0,25. The stroke length, which is 0,4 in meters. And also about this engine, we are given it rotates at the speed of the engine, 360 revolutions per minute. So we have got the speed, which is 360 revolutions per minute. Okay, so that's it. That's the information that we have. Okay, so we are going to see how the information works and what we are given. So the first part was to calculate the mean effective pressure. So the mean effective pressure in that case, all right, in this case that we have, the mean effective pressure, we are going to take it from the indicator diagram. That's the only information that is necessary so far, because we have the indicator diagram. So the mean effective pressure can be determined there, which is the height times what? The spring rate or the spring stiffness. The spring rate or the spring is per millimeter of what? Of the height. So we need the height there, per unit height. So the height, like I said, it is the area over the length. The area in square centimeters, which is 6,24 square centimeters. If we divide, we must use the length in centimeters also, so that we obtain our height in centimeters. So that will be something like 0,832, something like that. In what? In centimeters, because these are centimeters. So to millimeters, that's where you multiply by 10. So that will be 8,32 millimeters. So that means in this case, we could have used these units in centimeters. But because of what we are given now, because of what we have there, that it is supposed to be in what? In millimeters. What is supposed to be in millimeters? The height, per millimeter of the height. So that is why we have to change this to 2 millimeters. So we are simply going to multiply the height that we got in millimeters, 8,32, it's already in millimeters, times the spring rate in millimeters, which is 100 kilopascal per what? Per millimeter. This millimeter per and this millimeter cancels. We remain with kilopascal as our pressure. So that was going to give us 832 kilopascal. So that's our PM, which is the indicated mean effective pressure. All right. So the indicator diagram, it has played its role. We are done with this information. Whatever that we had on the indicator diagram, the area, this and that, it does not affect any other area of the cylinder. Whenever you talk about the area of the cylinder, you talk about where you have the diameter. This is our information about the cylinder. This is the indicator diagram. So do not confuse this area. You now take it where you are using the area for the cylinder. No, it's different. What am I trying to say? If we check this question that is following, they need us to calculate the indicated power. The indicated power. Remember that. I said that once you have got, remember, this is the indicated mean pressure. And if we have the indicated mean pressure, which formula are we supposed to think of? The plan formula. The indicated power is equivalent to the plan. Or you use the plus, where this is the indicated mean as given from our formula sheet. And we have this part. So the indicated mean pressure, we calculated this. If we use this in kilopascal, we said our answer is going to be in kilowatts. So this is 832. All right, let's fill in our information times the stroke length, not the length on the diagram. No, the stroke, we are back to the cylinder as it is. The stroke length of the cylinder in meters, that's 0,4. Remember, the area when given a diameter is what? Pi d squared over 4. So that is going to be pi times 0,25. This is 0,25. 0,25 squared over 4 like this times n. Remember that n is affected whenever you use the plan formula. N is affected by what? From the speed, and also it's a 4-stroke. So this one is a 4-stroke, and I said for a 4-stroke, n is equal to revs per second over 2. Whenever we're dealing with a 4-stroke. If it is a 2-stroke, revs per second over 1, then double acting, we multiply by 2. But this one, we are not told, so you act it as a single acting. It's a single cylinder, single acting. So revs per second, 360 revs per minute, that will be 360 over 60 like this. We now have the revs per second. But we are supposed to divide by these two. It's already in the denominator, so you just multiply by 8. So this is your n that you're supposed to substitute here. So you can simplify this, you get 3 revs per second, or you can substitute as it is like this, or you can substitute the simplified value, this one, which is 3, times the E, the number of cylinders that we have. How many cylinders? It's just 1. So this gives us the power, the indicated power, in what? In kilowatts. Since the pressure used there was in kilowatts. So let us multiply this. If we multiply this properly from our calculator, that is be 49,0008, something like that. So approximately 49. So it's going to approximate to 49 kilowatts. All right. There, I'm just going to take it as a whole number, guys. But it was actually something like this, 49. If you wanted to 3 decimal places, it was going to be fine, but it was going to be 49,008845, something like that. Okay, that's our indicated power. So that is how we play around with this information. So let's see another one. They want us to calculate the brake power. All right, take note. Calculate the brake power if the mechanical efficiency is 80%. If the mechanical efficiency is 80%, Remember the idea of the mechanical efficiency. We need the indicated power only. That is what we need. All right? Because remember we said in order for us to have the mechanical efficiency, I talked about this. This is the brake power over the ratio that we have to of brake power to the indicated power times 100%. So that means the mechanical efficiency that we are given there, it's 80%. So that's 0.8 if we remove this 100% is equal to the brake power that we need over the indicated power that we calculated, which is 49. This is kilowatts. So definitely our brake power is going to be in kilowatts. So if we cross multiply 1 times BP, that's going to be brake power is equal to 0.8 times what? Times 49. So that's 0.8 times 49 kilowatts. So having this power in kilowatts, we are going to have this as our brake power, which is 39.2 kilowatts. That's the idea. That's the idea. So you see the part of the indicator diagram, you have to be very, very careful how you are given your information. All right. Then I want us to consider another part that is called the indicator diagram. It was question number 3. All right. Question number 3, we are given this information. So you're going to try other questions. There are so many questions here that need indicator diagram. Just try them. Where there's a challenge, let me know about that question so that we can do it on another class. But for you to have all your questions that you need answered, make sure that you join the membership, which allows you to ask any question that is in our syllabus for N6. All right, anyways, let us see. I was saying on question number 3, we are given the information was obtained from a test on a single cylinder, So that is the number of cylinders. There's one 4-stroke. So this one is a 4-stroke. Okay, what else do we have? Then the engine is at the engine speed at 320. So the speed is at 320 revolutions per minute. Remember that whenever, if we are to use the formula plus or plan, this N is going to be affected whenever we are to use that formula for plan. The N that we need there, since it is a 4-stroke, is going to be revs per second over 2. That's revs per second, 320 over 60 to convert to revs per second, then we multiply by 2. So if you check, this one is going to be a decimal. This is that. So just leave it like that. Just leave it like that. All right. So this use it when we are using the plan formula. But in any case or in any calculation that you're going to do, when this is not needed, you are not going, you are going to use this as it is, this one direct. But when you are using the plan formula, there you are forced now to use that. All right, let's see on our information again what we are given there. All right, again, we are given that the area of indicator diagram, the moment that they gave us, it's an indicator, they gave us an indicator diagram. So this is from our indicator diagram. So from our indicator diagram, what do we have? We have got the area there from our indicator diagram. We are given the area, which is 780, that's 780 square millimeters. The length of indicator diagram, the length and also the length of the indicator diagram, 75 millimeters. The height we are not given. We do not have the height. Then we are given the spring stiffness per millimeter, which is, we have got the stiffness, the spring rate. So we are also given the spring rate there. The spring rate, which is given as 90 kilopascal per millimeter. So this is 90 kilopascal per millimeter, like I said, per unit what? Height. Then the cylinder diameter is 200 millimeters, which is 0.2 meters if you write this. And this one, the same, the stroke. So this one does not affect us here. We're just going to write it here, the diameter. If we divide by 2, that will be 0.2 meters. The stroke length divided by 2, that will be 0.35 in meters. Then also they are saying about the brake. The net brake load of 110 kilograms, the drum radius being 0.6 meters. So this is about the brake, where we find the brake power. So this is about the brake, where we are going to find the brake power. So there we are given on the brake, the mass of the load, which is the mass there, 110 kilograms, and the radius of the drum, which is 0.6 meters. All right, that's what we have, only this. So we are going to see our questions, but okay, as you can see, it's few information, just nothing there. Calculate the indicated power. On the first question, we need the indicated power. Okay. We saw that from the last question that we had, if we have an indicator diagram, what we have from there is the indicated mean effective pressure, which helps us to calculate the indicated power, since the indicated power is taken from the plan, because we are not given any efficiency that we can use. Even the brake power we do not have. So we are supposed to go back here. All right. So from this formula, what will be our indicated power? This one we do not have. That is the one that they gave us from the indicator diagram. Because we said from the indicator diagram, what is it that we find there? We find the indicated mean effective pressure, PM, which is the height times what? The spring rate, which is the spring stiffness. So it is given kilopascal per millimeter. Per millimeter. Our height must be millimeters. So like I said, height, guys, this is area over what? Area over the length. As we can see, our area is in square millimeters. Our length is in millimeters. So definitely, guys, square millimeters over millimeters. Your answer is going to be what? In millimeters. So there, I'm just going to substitute direct on the formula, because I'm going to obtain in millimeters area 780 over the length 75 times the spring rate. Already it's per millimeters, 90 kilopascal per millimeter. Remember, like I said, if we divide, our answer here will be millimeters, and this will be what? Millimeters. So millimeter here and millimeter cancels. We obtain our answer in what? In kilopascal, because this is kilopascal per millimeter. So this one and this one will cancel. So that was our pressure, meaning to say we have the indicated mean effective pressure in this case. All right. And that was going to give us approximately, it was directly 936 kilopascal. So with the indicated mean effective pressure, we can be able to calculate the indicated power. Because the indicated power, it needs this. Our indicated power is the indicated mean effective, which is 936 times the length from the cylinder, which is our stroke length, not from our indicator diagram here. What is our stroke length? That's 0.35 times the area from the diameter. I said this is pi d squared over 4. That's 0.2 squared over 4 in meters times n. Remember, we talked about this n to be used on the plan formula, how you're supposed to change your units about this n. So this is the n that we want, not this one as it is. You have to adjust depending with the strokes that you have. So we got there 320 over 60 times 2 times E, which is the number of what? Cylinders. How many cylinders do we have? Just one. Just one. So that will give us the indicated power in kilopascal. Why? Because we used this in kilowatts. Because we used this in what? In kilopascal, our indicated mean effective pressure. So our indicated power in this case was going to give us to 3 decimal places. It was going to be 27,445, like that. So this is kilowatts. This is power, the indicated power in this case. So in what? In kilowatts. Just like that. So we might need this indicated power. We might need this indicated power. So let us just put it aside. But it was 27,445 kilowatts. So remember also that kilowatts, it means kilojoule per second. That is kilojoule per second. Okay, let's see again on the same question number 3, the brake power. All right, the brake power. So the brake power in that case, if we are to consider this, remember that the brake power, we are given the information about the brake, just about the brake here, the mass and the radius. This information alone, it forces us to use the normal formula about the brake power. Remember, I said the brake power, 2 pi Tn over 60, where T is the torque there. How do we determine the torque? That is the force times the radius. Are we having the force? No, we do not. We are given the load mass, which is the mass. So the force is going to be mass times gravitational acceleration. That is our force. So according to our syllabus, guys, we are going to use this as 9,81. Your textbooks, yes, they can use 9, they can use 10, they can use whatever that they want. But us, we use 9,81 for this gravitational acceleration, 9,81 meters per watt per square second. So we have the mass. Therefore, our torque there was going to be the mass, which is the load mass of 110 kilograms times the gravitational acceleration of 9,81 times the radius of the drum in meters. We are given that. So thus, we are going to have the torque in this case. And by multiplying this, we are going to obtain our torque as 647,46 in Newton meter. So in this case, the textbook, they actually used G as 10 meters per square second. You use the one that you're given. All right, like I said, on our final exams, we are using G as 9,81. So be used to that. Unless you are told use G as, that is where you can use G as what you're given there. So now that we have this torque here, what are we going to do? Just substitute to calculate our brake power. And this brake power is measured in watts, direct in watts. So that is going to be 2 pi times the torque that we got, which is 647,46 Newton meters times N. There we use the revolutions per minute as they are. The only part that is affected on N, like I said, this one is used when you are using the plain formula. That's where you use the condition only when you are using this formula, only there. Not always you have to write this conversion. No, it's only there. Whenever you're using other part, any is any as it is. So this is going to give us the brake power. Like I said, that is going to give us the brake power in what? In watts. So to convert this to kilowatts, we can just do it here, times 10 to the exponent of -3. Automatically, we have converted our brake power to be in kilowatts. So to 3 decimal places, it's going to be 21,697 kilowatts. So that is going to be your brake power. So you need the torque in order for you to use this formula. All right, so these are the typical questions that they might give us. We just have to play around and see how do they ask these typical questions. All right, let's check number 3. Number C of the same question, calculate the mechanical efficiency. So as we mentioned before, that the mechanical efficiency can be taken from the brake power and the indicated power. We have the indicated power. Remember, we calculated this. We have the brake power, so we can use our formula. Remember, that is mechanical efficiency. So the mechanical efficiency, remember we said brake power over indicated power. Even from your formula sheet, you're also given this. So it's just an issue of substituting our brake power. The one that we got, if our torque, we used 9,81, it was 21,697. Like I said, textbooks, they can use any other value, 27,445 times what? Times 100%. So this is going to give us the mechanical efficiency. So the mechanical efficiency was going to be 79,056%. So that is the mechanical efficiency in that case. All right. So I want you guys to do as many questions as you can dealing with the indicator diagram. The most part there, as we saw that the indicator diagram, it was playing a major role. So you can see that there are questions that need you or to work with the indicator diagram. Like if you check on question number 6, it is also a typical question which needs us to use or to apply the indicator diagram. So we can try this question, but if there are any questions, let me know about that in the comment section so that we can be able to work on them. But like I said, guys, make sure that you also join the membership. By joining membership, you've got access to any questions that we have in our syllabus. Try to revise as many questions as we can, question papers. So joining membership is the way out. But for now, that's it, guys. Till we meet again.